Hello students, welcome back to my channel. So let us continue learning the data structure queues, okay, which we started in the last session. We have already seen what is the meaning of queue, what is the various types of them, and what are the operations which we perform on them. Today we are going to see how do we represent this queue in our memory, okay, using arrays and linked list, and also we are going to learn two algorithms. So let's start. The very first thing is memory representation of a queue using arrays. Okay. Now in the stacks also we had seen that we represent stacks in two methods, isn't it? Using array and linked list. So arrays and linked list are two very important data structure whom we use to implement many other data structure. Okay. So let us first see how do we do it using arrays. Now, when we are representing it in the memory using the array, we use a linear array. Okay, so linear array is nothing but a consecutive. It uses a consecutive memory location like a normal array. Now let Q be the linear queue. So here we are saying that let Q be the name of a linear queue or linear array. Now we are going to use two pointer variables in order to implement it. Okay, so what is this pointers? All that we are going to learn in the coming sessions. So as of now, you remember that there is a pointer which is pointing at a particular address. So in detail, when we are learning C++, I'm going to teach you what is this pointer variable, how can we declare it, how can we use it in the program. But as of now, you remember there is something called as a pointer variable which we can use to point at certain data representation, right? So two pointer variables we are going to use. One is front and one is rear. Of course, this is to implement our front and rear, which we have already seen in the previous session. Okay. The pointer variable front contains the location of the element to be removed. Okay. And the pointer variable rear contains the location of the last element inserted. Now this we have already seen that if Q looks something like this, always it has front and it has rear. Front is where we will remove the data item and rear is where we keep on adding the data item. Something like our normal queue, isn't it? So that's what they're saying. Front pointer always points at the front from where we can delete the data item. Rear pointer is pointing at the place where we can add the data item. Next, the condition. Now this is important. The condition front is equal to null indicates that the queue is empty. Now how is that? Suppose I have items 1, 2, 3, 4, etc. Then of course the front will have some value. Okay, whatever the subscript. Since we are representing this in an array, we know that our subscripts are there 0, 1, 2, 3, etc. Suppose my front is equal to null. If this value of this particular thing is null, then what does that mean? There are no more item at all. If the front itself is empty, if you're standing in a queue and there is nobody in the queue, which means that the queue is empty, isn't it? That the same thing is applicable here. If the first value of the queue itself is empty, which means that the entire queue is empty, isn't it? This indicates that the queue is empty and the condition. Oh, so this is the condition for Q is equal to empty. So why do we need that? Q is equal to empty condition. This we have already seen. This is called as a underflow. If our Q is empty and if we are trying to delete an item, so this condition causes an error and this is called as underflow. There is no item, but still we are trying to remove an item. Okay. Now the another condition, rear is equals to n, indicates that the queue is full. Now what do you mean by that? We know that arrays are always fixed, isn't it? Suppose my n is equal to 6. That means I can have 6 items in my array. So what is that? 0, 1, 2, 3, 4, 5. This is 5. Why? Because we are starting with 0. This I'm explaining many times because you need to remember it. Okay. So when I say my rear is pointing at 5, this is nothing but it is pointing at the 6th element, which is equal to my number of elements. So when my rear becomes number of elements, that means I cannot add any more items. It's not possible. So this is the condition for overflow, which means my array has reached its maximum possible capacity, and if at all I still try to add any element, I cannot handle it. So this is an overflow condition. So this indicates rear is equal to n, indicates that the queue is full. Okay. So these are the two conditions you need to remember. One is for queue is empty when front is equal to null, and when rear is equal to n, the queue is full. So this condition we are going to again and again use in our algorithms also. Okay, I hope these representations are clear. Now, see this image. With this, it is going to be all the more easier. So this is the memory representation of a queue using array. So how do we do that? Now here, this is a normal array we are using with these subscript. So my item is here. So my front is going to point at the first element and my rear is pointing at the last element. Okay, so here front is equal to 1 and rear is equal to 4. Now, when I say rear is equal to rear plus 1, what is going to happen? Rear is equal to rear plus 1. Rear value is 4 plus 1 when I say 5, isn't it? This is going to become 5. So the pointer has moved from 4 to 5. And also I am saying Q. So what did I say in the beginning? I said that Q is the name of the array. So when I say Q of rear is nothing but Q of 5, which is this value is equals to E. So this is how I am going to add an item into the queue. Okay, what I'm going to do, I'm going to say rear is equal to rear plus 1. I'm incrementing the pointer. And then in that place, I'm going to say Q of rear is equals to whatever the element I want to add. Now let us see how am I going to delete an item. So we are always going to delete the item from the front pointer, isn't it? So first I'm going to store that item whichever I'm deleting. So what I'm going to say, I'm going to say item is equal to Q of front. So here as of now Q of front is what? This is my A. Okay. So I'm going to store what I'm going to store. I'm going to store A in my item. Then I'm going to say front is equal to front minus 1. Where is my front here currently? It is 1. So when I say 1 plus 1, it is going to become 2. So my front is going to come over here. So that is what has happened here. So automatically I'm saying that I have deleted the data item here. Right. So what is going to happen in deletion case? Using the array, I'm going to store the item is equals to Q of front. So whatever the value is there, that I'm going to store it in item and then I'm going to increment the front pointer. So this is how a deletion operation is done in Q, which is being implemented using arrays. Right? I hope this is clear. Next, let us see how do we do this using the linked list. Right? Now, memory representation of a queue using linked list. Linked list, I had briefly explained it to you all in the start section also. So the coming data structure which you're going to learn is linked list. But briefly, I had explained how it works. We have a head, then every linked list will have a node and the node contains of data item and the address of the next node, isn't it? So this we had learned in the previous session. So the pointer front contains the location of the first node. So front is going to be represented by the first node and the rear is going to be contains the location of the last node. So rear is going to be the last node. Okay. So what is going to happen if I have to add an item into this linked list? So what I'm going to do, I'm going to remove this null and I'm going to write the address. Suppose there is a node over here. I'm going to write the address of this node. If it was 75, then I'm going to write 75 here. Okay. When I do that, automatically a link is going to get connected to this node, and in this node I'm going to write the value. Okay, so in this value is also same. Suppose this is 100. Okay, so I'm going to say 100 here. So when I say that address, it is going to get linked. So this is the data item, and this one I'm going to say null. Why? Because we always add item at the end. At the end, the node should always have the value address null. So this I had already told. So if you remember, so here it was null. So I'm going to remove that null and I'm going to write the address of the node which I'm going to add in my queue. By doing that, I will be adding this particular node to the queue. Okay, so this is how addition is going to happen. And deletion is also in a similar manner. So how do we do the deletion? Suppose I want to delete. So in this case, we have deleted the, of course, we are going to delete it from the front, isn't it? So queue, how does it work? We are going to remove the data from the front. So this I want to remove. How do I do that? So remember that Suppose this the address is 100 here, this is 200 here, this is 300 here. This link means that I'm going to store the value 200 here and I'm going to store the value 300 here, isn't it? Now, since head is linked over here, this means that 100 is stored in the head. Now I am going to remove this 100 because I want to remove this node, and I'm directly going to store 200 over here. So when I do that, what is going to happen? The link is going to break from here and directly it is going to come and go get linked here. Now what's going to happen? I have deleted this particular node. Right. So see here, now head is directly pointing at this particular node. Okay, I hope this is clear. You have only this much to learn. There is no much theory or the algorithm in order to do the deletion into a linked list or addition into a linked list. Linked list we are going to learn in detail in the coming sessions. So as of now, understand the basic concept. Okay. Next, we have algorithms. We are learning two algorithms now. The first one is insertion. So here we are using the array. Okay, so we are using the array for insertion and deletion. Already we have seen this in a theoretical way. Now let us see the algorithm. So here we are using queue. The name of the queue is queue, be a linear array consisting of n elements. Front is the pointer that contains the location of the element to be deleted, and rear is the contains the location of the inserted element. Okay. Now item is the element to be inserted. This I have explained already. Let us see once again. So if rear is equal to n minus 1, what is this condition? This we discussed. When rear is equal to n minus 1, this is nothing but, suppose I have an array and it has 0 to n minus 1 elements, isn't it? If my rear is already over here, this means that I cannot add any more item because I have reached the limit, isn't it? So this is a condition for overflow. Since this algorithm is an insertion operation, we are going to check for the overflow. If my array is overflowing, I cannot do the insertion. I am going to directly exit, right? If at all it is not true, suppose my R is over here, then what is going to happen? Let us see that. In that case, if front is equal to null, so again we are checking. Once we check for overflow, I am checking if my front is equal to null, if there is any value over here. If it is null, then check whether Q is empty. Okay. If it is empty, then I'm going to say F is equal to 0 and rear is equal to 0. So what I'm saying, F and rear both are at the same position because front is empty, isn't it? So if my Q is empty, my front is also going to be the same thing, and my rear, the end of the queue is also going to be the same thing, isn't it? So that is what I'm saying. I'm going to say the front and R both are 0. Else, if in both the cases, first case was what? The stack was full. Second case was stack is empty. Third case is where my stack is half, sorry, not the stack, the queue is half full. It is not empty also, it is not full also, isn't it? In this case, we can easily add items. We can add items in this case also. We can add item in this case also. So what is going to happen in this case? In this case, we are going to say that rear is equal to rear plus 1, which means I am moving my rear pointer to the next position. And then I'm going to say Q of rear is equal to whatever the item. Suppose I want to add 5 here. Then I'm going to say Q of rear. So when I say that, it means that this position, add that particular item, copy the item into that position. Okay, so that's all this algorithm is all about. So there are 3 conditions. First, when we are going to check is if my front is over here, okay, suppose I have 1, 2, 3, 4, 5 and my rear is over here and the maximum number possible has reached. So this is my first condition, which is my overflow condition, right? Next case is where my queue is empty. Okay, so when my queue is empty, I don't have any data item. I'm going to say F is this and R is this. And what am I saying? I'm going to say that Q of rear is equal to item. Okay, in this case also, I'm going to add the item at the end. I'm going to first say this both are same, and then I'm going to add the item at the rear. Third case is where my queue has few items, but it has not reached n minus 1 yet. So it is somewhere over here. In that case, I am going to increment my R and then add that particular item, which is nothing but this line, third step. Okay. So this is my first step, this is my second step, and this is my third step. I hope this is clear. Next, let us see how do we do the deletion of an item in an array. Now, same condition we are going to use. We are using a linear array. Okay, so Q is the name of the array. Front is pointing at the front and rear is pointing at the rear. And we have n elements here. Algorithm deletes the item from the front, of course, because in the queue we are going to delete the item from the front. So what are the conditions here? First, we are going to check for the underflow condition. That is, if my queue is empty, I cannot delete it. So what is it? First condition is my queue empty? That is, if f is equal to null. Null is nothing but if it is no value here. In this case, we cannot do the deletion. So this is my underflow condition. Okay. Otherwise, what I'm going to say, in any other cases, even if my rear is at n minus 1, that also that is doesn't matter. But unless until there is even single element in my in my queue, then what I'm going to say, first I'm going to store that element into item. First I'm going to save it somewhere. Okay, suppose there is 5 here, I'm going to say it is 5, item is equal to 5. Then I'm going to check if front is equal to rear. Suppose, why is this front is equal to rear happens? When does that happen? When we have only one item. Suppose I have only one item, then my front is also same and my rear is also same, isn't it? In that case, if we are deleting this particular item, then what we are going to say, once we delete it, I'm going to say front is null and rear is also null, which means there is no more any item left in this, because we had only one item left here, that also we have deleted, right? So if the once we save the data item, we are checking if the front is equal to rear, which means if there is only one item, then in that case we are going to say both are null. Otherwise, in this case where I said that rear is somewhere over here and front is here, I have already saved the item. I'm directly going to move my front from here to here. So when I do that, I'm going to discard this. So this is going to get deleted now that my front is over here. Okay. So we are incrementing the front pointer. Easy, isn't it? So this is how a deletion works. We are going to check the underflow condition. Then we are going to check if there is only one element. And then if not, we are directly going to, if there is one element, then also we can delete the items and we are directly going to say that front and rear are null now from now on. And otherwise, I'm directly simply going to save the data item into some other data and then I'm going to move the front pointer. So next we have applications of queue. What are the applications of queue? Now queue is used in many places, okay? Mainly where we are going to stack the So next we are going to learn what is the applications of the queue. Now, applications of the queue are simulation, various features of operating system. Now, operating system, you should know that when you are working on a system, right now when you're looking at the system, the operating system is performing so many multitasks. So how does it do? It is going to keep the processes one after the other, okay? And how does it keep? It keeps it in a queue, okay? So as in one new processes comes, it keeps it in the queue and it keeps processing one by one. So it is going to remove it from the front and it is going to add it at the rear. So this is how operating system works. So operating system often maintains the queue of processes that are ready to execute or that are waiting for particular event to occur. This particular event can be, it may be waiting for a memory, it can be waiting for the CPU time, etc. Okay. So queue is used mainly in operating systems. Multi-programming platform system. So here also multi-programming, what do you understand? There is multiple programs happening, so it has to wait for certain things. So this waiting happens always in a queue. Different types of scheduling algorithms. Scheduling algorithms are nothing but round robin, first come, first in. There are so many scheduling algorithm where we schedule the CPU time for a given processes. Okay, even they follow the queue system because the processes need to wait for the CPU time. Round robin technique algorithm, printing. So printing, you might be knowing, if you're giving back to back printer, that a window pops up where there are printer to waiting in the line to get printed, isn't it? That is also a queue system. Here also the queue is getting implemented. Various application software also based on the queue data structure. Operating system often maintain queue processes that are ready to execute or that are waiting for the particular event to occur. So mainly it is used in the operating system and printer. This round robin, everything is also a part of operating system because mainly processors are waiting for the CPU time, memory, and so many other things, right? So this is a very big application. Because of queues we are able to do multitasking in our systems. Okay, so that is why we might think that where do we use this, but knowingly unknowingly we are using it in many places, many important places, right? So this is all about queue, students. In this data structure we have completed the queues data structure also. So hopefully this is helping you all in your preparation. Okay, thank you for watching. Take care.